Hi, math lovers. Welcome to notes number 8. We're on lesson P5, the prerequisite chapter, and we're going to talk about rational expressions. The first thing we have to define today is our domain. Our domain is a set of numbers for which an algebraic expression is defined. So it's the numbers that you can put in, the set of numbers you can put in to make your expression work. So first off, let's think about what our domain is. First thing I have here is just a regular old-fashioned polynomial. And do I have any restrictions on what I can put in for it? No, absolutely nothing. So I would say my domain here is the set of all reals, okay? The second one I have here is the square root of x minus 7. Now, we're talking about real numbers, but here's the problem. If I put a number like 0 in for x, I would have the square root of negative 7. That is not real. So underneath this radical sign, and anytime you have radicals, whatever's underneath that radical sign, x minus 7 has got to be greater than or equal to 0. So what you need to do is to solve that. So you would say that x is greater than or equal to 7, okay? So formally I would say all reals, and then x is greater than or equal to, such that x is greater than or equal to 7. Same thing with my fraction. I have some restrictions on my fraction here. Remember, my denominator cannot be equal to 0. Remember, go back to your elementary school. Why can't it be equal to 0? Elementary school, fractions are always pizza. Take the denominator, that's how many pieces of pizza your pizza gets cut into. All right, so if I have 1 over 0, let's take that pizza and cut it into 0 pieces. That doesn't make any sense. Fractions, the denominator must be an integer. So what we're going to do here is we're going to take this denominator, whatever your denominator is, x plus 1, and we're going to set it equal to 0. It can't be equal, well, actually, it can't be equal to 0, right? So we'll solve that. So that's x is not equal to negative 1. So I would say all reals such that x is not equal to negative 1, and that would be my set. Okay, we're going to do some quick simplifying over here on the other side. I've got two problems for us to give a try. First one, we've got a fraction times another fraction divided by a third fraction. You know, divided by a fraction is the same thing as multiplying by the reciprocal. So we could say x over 5 times 25 over x squared, or x times x if you feel like it. And then the reciprocal, which would be 2 over 1. And, you know, for fun, you could go ahead and you can divide things out. 5 goes into 25 5 times. X goes into x 1 time. And so you are left with 5 times 2, which is 10 over x. Now, I don't have to say to my reader, hey, x is not equal to 0. Formally, if I said to you, what's the domain, you would say x is not equal to 0. But if I just was asking you to simplify, you don't have to go ahead and say x is equal to 0 unless I specifically ask for the domain. It's understood that your reader is smart and your reader knows if it's looks like this where I can see that x is in the denominator, I don't have to say it specifically. Okay, a little bit different next problem. So I'm going to take my rational expression here. I'm going to go ahead and I have to factor this. So let's factor the numerator. Let's see, factors of 12. How about 4 and 3? Again, I prefer to go in the order that it's given. There's no reason for you to go ahead and switch the order around. All right, try to fight the urge to do that. That's always something in Honors Algebra 2 that the kids always want to do in Chapter P. And then the denominator, we've got to factor that. I'm thinking 2x. 4, how about x, 4 and 1, is that going to work? 8 and 1, yeah, that's going to give me my 9 that I want in the middle, okay? Now you're staring at it, friends. Do you see the exact same factors? Probably not, but do you notice this x minus 1, 4 minus x and x minus 4, all right? So off to the side, let's think, if I have 3 minus 2 over 2 minus 3, all right? So that's going to be 1 over negative 1, which is negative 1. I could have 7 minus 5 over 5 minus 7. What's that going to be? That's going to be 2 over negative 2, which is negative 1. So a nice little trick to put in your pocket and keep this around. A minus b over b minus a is always going to equal negative 1. Always going to equal negative 1. So what you're going to do here is you'll divide those out. You have a negative 1 here. Now, notice that I've divided out the denominator with the x minus 4 in it. My final answer, personally, I would like to leave that negative 1 there, just my style. If you'd like to distribute that -1 back around, you can do that. But because I crossed out this x minus 4, I need to tell my reader, hey, x cannot equal 4, because that's going to put a 0 into my denominator, and we just can't do it. So if you divide out the denominator, including your answer, all right, it's implied here that x cannot be 1/2, because we still have x minus 1, 2x minus 1 in the denominator. But as soon as you divide something out, then you've got to go ahead and you got to move it. All right, so you have fun, play with your problem set. Enjoy.